Hello. Now we are going to present you how artificial intelligence in telephony systems and solutions can be embedded, and we are going to share with you how those solutions can be integrated in voice telephony systems. First of all, my first lesson with telecoms was to define that in a phone call we have two layers. The first one control the call establishment and of course the hang up, and the second one manage the voice transport. So artificial intelligence can act in both layers. The first one, associated to the establishment of calls, you can receive call and signaling events that can be catched by a system and analyzed to process, as we see, fraud detection and dashboard generation, for example. This is a kind of solution developed by Oracle, for example, that connects to the SBC, get those events, and can alert on suspicious traffic, for example. But in phone calls, the main use is to transport the voice between the two users. And in these channels, we have a lot of data, of content that we can analyze with very complex artificial intelligence tools. And so that's those tools that we are going to present and share with you how that works and how they can add values to telephony systems.
Thank you. So actually, maybe we missed one part, which is we didn't introduce ourselves.
I'm sorry.
So Borja, go ahead.
So sorry, I lost my introduction. I am Borja Sixto. I am the co-founder of the Ulex company, and we develop IVR systems with natural language.
And I'm Karel Bourgois. I'm the founder of Voxist, and we develop speech recognition systems.
I don't know if you hear you.
And I don't know if people can hear me. Okay. Maybe my head is... Okay, I'm talking like that. Probably works better. So Karel Bourgois, I'm the founder of Voxist, and we do speech recognition software solutions. But so, you know, among things you can do with AI around the speech itself, there are some interesting use cases.
Trying to keep the two of you apart.
Yeah, go ahead.
When you get close.
Yeah, sorry. You can do speech enhancement. So speech enhancement is actually things that we've been doing in the telecom industry for a long time using analogs. But you can do eliminate noise. You can eliminate specific noise like music, wind, or any type of background audio you want to get rid of. But you can also make the speech easier to understand. So, you know, if you're in call centers, you receive calls, sometimes people don't speak very well, they have accent, etc. So you can use AI to do all those use cases. And one thing also we've seen very recently is around new codecs. So Meta did a paper where they say that with AI they can get 10 times more compression level than what you can do with the state-of-the-art compressions. And another thing for sure is voice biometrics. So we are talking about, you know, passkey and how you can identify users. So voice is a very good way of identifying user. There is a lot of issues on the regulatory side because of the GDPR, but you have some great solutions that are being used either for authentication or for identification. Now, you know, so for those of you who were there last year, I was talking about speech recognition. I was showing, you know, the old way of doing it is where you have different steps where you have to get the audio. From the audio you get the phonemes, and you put the phonemes together. So that was the old way of doing it. It was really complex. And I showed you how we can do it now with end-to-end models, but things already moved out. Very fast. So last year, just after I think that summit or around that summit, Whisper went out with a new way of doing it using what we call encoder-decoder. And now we have all the LLMs So the next generation, I think, are going to be around that type of architecture, where you mixed the speaker recognition of an encoder-decoder with the LLM, so the LLM can actually understand the content. And directly at the end, you not only have the transcription, but you have information like there was a train in the background, the people were happy, the people were not happy, etc. And I'm going to give you a short demo of what we can do currently with that type of integration where we mix LLM with transcriptions. So this is an audio that I'm going to play. It's in French, so right now I'm sending it to transcription text a little time. But what's going to be interesting is probably none of you will understand it. It's in French, but I don't understand it either. Oh, sorry, I need to have the sounds much higher. Okay.
Jupiter scanner server électoral couple de plugins disponibles, bilan pour la ligne technique de pôle ligne, injection sensible pour de pôle ligne, crainte de pôle ligne. Les structures multinationales sont place système en fait que l'état normal point, pas d'émergence entre place serveur point, pas de données dans ce point chez serveur point.
So this is a doctor talking. He's talking so fast that you can barely recognize the words. And even if you did recognize the word, the vocabulary is just like so freaking complex. So, but that's what the ASR end up doing, mixed with LLM. They can understand what's the indication, what are the conclusions, what are the different domains that are being talked of. And so not only you have a retranscription, but you have actually the real meaning of what the doctor is saying. So that's some example of the use case that we will be able to do more and more with this mix of ASR and LLMs. And I let you go on the other side of that.
After listen, the system can talk, and of course, to talk, the system use neural synthesis voice. I think everyone already listened a bot with a synthetic voice, and that you detect that it is a voice. Nowadays, new technology allows you to have a very natural and expressive voice. I give you an example from 11 Labs. It's a very young startup, and just listen what you can integrate in a phone call.
Hey there. Did you know that AI voices can whisper? Or do pretty much anything?
Ladies and gentlemen, hold on to your hats because this is one bizarre sight. We have reports of an enormous fluffy pink monster strutting its stuff through downtown.
Fluffy bird in downtown? Weird. Let's switch the setting to something more calming.
Imagine diving into a fast-paced video game. Your heartbeat sinking with the storyline. I gotta go, the aliens are closing in.
That wasn't calming at all.
Explore all those voices yourself. Hey there. Did you know that AI voices can whisper?
Okay, I think it's enough. As you see, the voices have a very high quality. Of course, when you play with this voice in IVR systems, the quality of the response should be adjusted to that. Another technology that we use after having the ability to understand, or better say, to listen the user and to speak to them, we need to understand what they are meaning. So to understand what users are meaning, we use natural language understanding, that it's technology that detects from text what is the intention of the user. So this technology uses artificial intelligence with a specific training where you can define the main subjects that the system should understand. Once you have all these Lego bricks, you should define what is the call flow or the dialogue flow from the user. Nowadays, most of the solutions used in the market use a low-code or no-code solution that generally is a graphical interface when you put blocks and you join the blocks with wires and you define what is the call flow of the user, and for each blocks you can define what the system should say, and what he can expect from response from the user. The last solution that we see and we work with is now complete changing the model to create this voice agent is to use solution with LLMs like ChatGPT. In this case, there is no longer graphical interface, but you use prompt, as we see yesterday, a super prompt from Paul, where we define the instruction and the condition where the system should answer. So we should take care about the solution because they are not always GDPR. And of course, we have hallucination from this system that should be controlled because in customer care services, you should control what you say to the customers. So now we are going to explain different use cases. This bridge can be used to create added values.
So we saw, I think, some example of that yesterday, but so the idea of doing speech analysis on an offline manner. So the idea here is more for call center example. At the end of the day, they have a mapping of the customer satisfaction level. What are the words that are being used? So we use all the voice conversation and we do text mining. We do things like knowledge management also for that. So from all those conversations, you can find out what people are talking about, who is not eligible in such area. So, by example, we work with Fortune 100 companies. We use that because they have so much knowledge worldwide, and they don't always know who are the knowledgeable persons. So they can identify subject matter experts using conversations that they have. And that allows us to allow a company that uses those technology to create those type of dashboard where you see the type of subject that's been used during the day, the type of conversation, if they are happy and not happy, the volume issue, etc.
So the other use case is to create virtual agents with many goal is to welcome users and identify them, route their calls, for sometimes the system cannot answer directly to the answer because it was a complex process to do. And of course, sometimes for a simple task, the system can be autonomous and be able to solve the problems that customers request from the phone call. Excuse me.
But nowadays you also do outgoing calls.
Yes, in this case we can of course process incoming calls, but we can generate campaigns and use artificial intelligence and natural language for outgoing calls. So we are making nowadays several campaigns to test the reaction of the user with this kind of systems that use natural language.
And if I remember well, you were telling me yesterday one of your campaign they compare to what they used to do with human, and they have a better conversion rate with the.
Yes, in fact, that we see that you have very natural voices, but we can use pre-recorded voices too. And what we are trying to test is the reaction from a user when the exchange seems to be a human. Because when you talk to a human or when you answer to a human, your reaction is not the same. When you see that it's a robot, I think it's like when you speak to a child, you adapt the interaction to this mode. So increasing the voice, increasing the capability of reacting, change the way to interact with this user and change the return of what the user can say or how they can explain their issues.
And surprisingly enough, some people prefer to talk to robots than to humans because there is less emotion and less empathy. And so you were telling me that for some companies that helps actually because the people don't like to engage with a human and talk about personal problems, etc. So at the end, AI sometimes is a better communication channel than human. I'm like not like that. I like to talk to humans. But sorry.
It's your turn.
And yeah, and another way of doing it actually for a use case where you want to talk to human, but you can use AI to augment the human agent. So it allows them during the call to have less to concentrate on what's being said because the data is going to be automatically cached by the AI and then input in their CRM, by example, and so they can be more focused on the human part of the conversation, the emotion parts eventually. And you can do a lot of things through the call summaries also. So nowadays we see that more and more for Zoom-like meetings where you have this AI that will give you a summary, but that's also something that's very useful for call centers. So at the end of a call to have in the CRM system a recording of the main topic, of what was being said. You can use also that for compliance issues. So in certain area like banking and insurance, where you have certain things that need to be said from a regulatory point of view. Until now, you will record, and if there was an audit, then you have to listen to the recordings. And now you know at the end of the call immediately, did the agent say the proper thing? Did he forget to do that? And so the supervisor can remind them of the specific things. So in conclusion, I think we've seen that over the last few days. What's amazing is AI is going everywhere within the telecom field, because it's on the signaling, we talk about fraud, it's on the voice side, both to understand the voice, to create voice, and then to create all those conversations. So there is a lot of value that can be added. Now there is also a lot of hype, and we can't replace all the conversation with AI. There is a lot of issues around. We are talking about hallucination, so you have to be very careful, and so your models need to be trained. So by example, the example I gave earlier in the medical field, the way we use it is that there's still a human at the end who control everything, because we will not use the output of the AI directly if there is any error that could be pretty problematic. And another thing also is we hear a lot about open source solutions, and so people are thinking, wow, why do you still have those companies? You're all dead because they're open source solutions. But the thing is, the reality of the production is you can't just take an open source solution and put it in production. Well, you can, but you have to spend a lot of effort to do that. So for a lot of companies, it doesn't make sense. It's not their business, their core business to do AI, and so they could do speech to text using an open source, or they can work with any of the company that specialize in that. But it makes more sense, because if you need to do all the integration, the productization of those solutions, it's very complex. And one of the things that Borja is working on is really how to, and you should explain that better than me because you're doing it, but how you bring all this solution together in the conversations.
Yes, three aspects. The first is the tuning. Those technologies need an adaptation to the context, so you need to get a lot of data and make some improvement with the various cycles. The real time. We speak about voice, and users need to have quick answers in terms of voice. When I finish to speak, I need the feedback from the system. So when you use the transcription, the natural language understanding, and the text-to-speech, the response time should be shorter as possible. And as we see that we start using ChatGPT and large model language, those technologies have real costs. It seems to be very powerful, but the economic model is not always very clear in terms of use.
Well, thank you very much, and we're happy to answer any question.
So as you say, the user needs to get the answers fast, and as Karel was explaining, maybe the speech-to-text will probably be merged somehow with large language models at some point to get a better understanding of everything. Do you think it will be necessary to also get the text-to-speech into the same thing and have some extreme end-to-end training to be able to get the latency down? For the model to understand as it's going, the large language model to understand the meaning of the conversation, to, for example, adjust the tone. Should it show empathy? Should it show anger? Where do you think the big bottleneck is to make it as a really natural speech? Because I know that the high quality text-to-speech is rather slow.
Concerning the reactivity, of course, we can join the transcription and analyze in order to improve the response times and take care about the emotion. For us, we are not very clear with this subject because we think that machine with emotional, with the care of emotional, it's complex to first to detect. It's not we have not a very high accuracy, and we don't know if we really need to change the attitude and the response relative to the emotional status of the user. So I know that there are some companies that are working on these terms. For us, what is more important is that the answer should be the right one. Okay, I think the emotion can be generated instead of captured.
What is at the moment the big bottleneck for the delay? Is it the large language model or is it the text-to-speech?
I think it depends on how you structure your dialogue. For example, if you ask a closed question, you can be very reactive because you are going to tune the way that you catch this answer. But if you have a very global question as how can I help you, in this case you should listen and of course be able to allow that the user could hesitate and make a pause, and in this case the reaction time could be longer.
And I think there is another part of that, which is the business model, as he was saying. So the fact that you have 3 layers in a way, kind of understanding the audio, creating the answer, and synthesizes the audio of the answer. It also, it has a latency impact, but it has a cost impact. I mean that we have 3 models potentially, so 3 GPU usage in parallel. So putting those more and more together allow you to gain into latency, but also will probably lower the cost. And to answer your first question, so there are things being done in that field at Meta in particular, where they do speech-to-speech. So you can go from speech directly to another speech without going through the text first, but they don't yet have the kind of LLM part integrated into that. So I'm sure there are going to be things in that field in the coming years, but for now it's nothing you see in production yet.
And of course we have improvement in the process. As I said, we can adjust the timeout for the reactivity in function of the question. We can use regularized question because sometimes most of users always say agent to be transferred to the agent. So we don't need a large model to detect this short word. And the text-to-speech can be cached. If we use always the same content, this content can be directly available and don't use always a system that converts the text to voice.
Any other question?
Yes,
Thank you very much.
That was excellent. Thank you so much. Great presentation.